start off, I'm going to be doing a backflip. I bring my arms down and then explode upwards, bringing my 58 kilograms up into the air. I then tuck into a tight ball to rotate over. At my highest point, I wait for the rotation to finish and then kick out. In this free fall problem, we were able to determine the total height of the flip based off of my weight, the acceleration due to gravity, and the total time in the air. In this example, Chase will be doing a precision front flip. He jumps out at about a 50-degree angle. When he reaches the far object, he absorbs and then throws up into the tuck. Chase jumped with a horizontal component of about 2.2 meters per second and vertical component of about 1.6. He then continued his momentum forward while throwing at about a 30-degree angle for the front flip.
There we go!
In this next movement, called a wall-up, I use the wall as a focal point to push out and away to get the maximum height. I then grab the ledge and pull myself up. In this problem that shows friction, we were able to determine that the coefficient of friction was greater or equal to 1, based on the fact that my foot stayed on the wall and didn't slide. What Chase demonstrates here is a version of a cat leap. The key to this movement is to stop your momentum by landing with your feet slightly before your hands. You then pull yourself up and over. For every action, there is an equal and opposite reaction. So when Chase hit the wall with a certain amount of force, the wall pushed back with the exact same amount of force, resulting in an acceleration of 0. The roll is an important movement for safety in parkour. When landing, it is better to dissipate the impact over a larger expanse of land than landing in one spot. Because I'm coming down at an angle, the reaction of the ground will push me back at an angle. Therefore, it's much easier to go with it than to try and stop myself immediately.
In the side flip, I plant my feet to generate friction, which gives me upward momentum. I also throw my arm up in the air and wrap around to make centripetal force and then come out of the flip.
In this movement, I use the wall as a focal point again, but instead of pushing out and away, I direct my momentum upward and let my legs fly up and over my head. To take a closer look, I'm using friction and centripetal force to bring me around. Since my shoes stayed in the same spot on the wall, the frictional force was equal to or greater than my normal force.
In this example, there are two components. One, the precision of me landing on the foot I took off of. The second one being me swinging my legs through to generate momentum to keep on going.
In this Kong vault, I change horizontal momentum into upward momentum at an angle. The act of tucking and then slapping the object brings me over. In this precision jump, I need to direct my momentum outward as well as upward. I jump out at around a 60-degree angle. I do this in order to get up high enough to reach the object higher than when I was standing before. When looking closer at the jump, I cross an expanse of about 2.7 meters and go up about 0.45 meters. When doing the calculations, we realized that the horizontal component was 6.7 meters per second, while the vertical was 3.92 meters per second.